All right, this is the final lesson in Unit 6. The lesson is called Graphing Exponential and Logarithmic Functions. So hopefully you have the basic idea of what these graphs are going to look like ahead of time from the last lesson where we analyzed graphs. We have 6 examples today. The first 3 examples are going to be exponential functions, so they're going to have horizontal asymptotes. And the final 3 examples are going to be logarithmic functions, so they're going to have vertical asymptotes. Okay, so I'm going to make a table for these. So we have x, then we have f of x equals 2 to the x power. So this graph is not being shifted up or down. So that means that the horizontal asymptote is going to be right here at y equals 0. In other words, the x-axis. Okay. But I'm going to make a table. Let's go with -3. Let's go with -2. Let's go with -1, 0, 1, 2, 3. And let's do the easy ones first. When x is 1, 2 to the first power is 2. When x is 2, 2 to the second power is 4. When x is 3, 2 to the third power is 8. Easy so far. When x is 0, 2 to the 0 power, you should know this, anything to the 0 power is always 1. So 2 to the 0 power equals 1. Now let's do the pesky negatives. When x is -3, that means we have 2 to the -3 power, which equals 1 over 2 to the +3 power, which equals 1/8. That's a property we talked about earlier in the class. When x is -2, that means we have 2 to the -2 power, which equals 1 over 2 to the +2 power, which equals 1/4. And then when x is -1, we have 2 to the -1 power, which equals 1 over 2 to the first power, which is just 1/2. So now you're going to graph this. You can see how close the graph is getting to 0, but it's never actually going to touch 0 because it has a horizontal asymptote at 0. So let's graph these. I'll do the easy ones first. 0, 1. We have 1, 2 from the table below. We have 2, 4 from the table below. Then we had 3, 8. And we never actually touch 0 because that's the asymptote. So we have -1/2. You can just estimate that one. That's good enough right there. We have -2, 1/4. And we have -3, 1/8. So again, when you graph it, you want to make your graph look like this. There we go. You want to make sure you don't accidentally just like keep going below, like this. So some people might do that accidentally. This one has a horizontal asymptote at y equals 0. If you're shifting up or down, the asymptote will change. But this one, you're not shifting up and down. We started with an easy one. So that's the horizontal asymptote, y equals 0. And this is your graph right here. Okay, let's do another one that's a little more difficult. F of x equals 1/2 to the x power plus 3. So that first graph, that was exponential growth because the number that was being raised to the x power was 2. This one, the number being raised to the x power is a fraction between 0 and 1. So that means it's going to be exponential decay. So let's make our table. We have x. I'll copy down the function over here. 1/2 to the x power plus 3. Oh, by the way, that plus 3 means we're shifting the graph up 3. So my horizontal asymptote is going to be at 3 now. Okay, just a heads up. You should know that ahead of time. So for the x's, I'll go with -3, I'll go with -2, I'll go -1, 0, 1, 2, 3. Okay. Let's start with the easy one. When x is 0, 1/2 to the 0 power is 1. 1 plus 3 is 4. Anything to the 0 power is 1, and then 1 plus 3 is 4. When x is 1, we have 1/2 to the first power, which is 1/2, plus 3 is 3.5. When x is 2, 1/2 times 1/2 is 1/4, plus 3 is 3 1/4. When x is 3, 1/2 to the third power is 1/8, plus 3 is 3 1/8. So you can see we're getting closer to the asymptote, which I told you was 3, because we're shifting up 3. See, this means we're shifting up 3. But we're never actually going to touch 3 because that's the asymptote. Now let's take care of the pesky negatives. When x is -3, we have 1/2 to -3 power plus 3. So that's the same as 2 cubed plus 3. Because you take the inverse, you reciprocal 2 to the positive 3 power. So that's 8 plus 3, which equals 11. When x is -2, it means we have 1/2 to the -2 power, which equals plus 3, which equals 2 cubed plus 3. 2 squared plus 3. They take the reciprocal, which is 2 over 1, make it positive 2. 2 squared plus 3 is 7. 7, let me make that nicer. All right, now the last one is 1/2 to the -1 power plus 3. Okay, think of 1/2 to the -1 as 2 over 1 to the positive 1 plus 3, which is 5. And now let's graph our table below. So we had -3, 11. That's going to come off my graph. I'm just going to estimate it right there. The graph goes up to 10. I just put it right there. Okay. -2, 7. Yeah, I'm just looking at the table below. I can't fit it on my screen right now. Then we had -1, 5. Then we had 0, 4. Remember, the asymptote is 3. I told you that at the beginning of the problem. So don't go past 3. We had 1, 3.5, estimate. We had 2, 3 1/4, estimate. And then we had this one. So now when I graph it, I'm going to make it look like this. Just give me 1 second. Exponential decay. Do not go below 3 because you should know that's the asymptote. Okay? One more exponential, and then we'll get to the logarithms. F of x equals 3 times 2 to the x minus 5. So what is the asymptote going to be? Think about it right now. Pause the video if you have to. But this one's being shifted down 5, so the asymptote's going to be at -5. So some people like to graph a dotted line there to help them know that's the asymptote. You can if you want. I'm not going to do that, though. So let me copy that down here. We have x. Then we had f of x equals 3 times 2 to the x power minus 5. For the x values, I'm just going to do 5. For this one, I'll do -2. I'll do -1, 0, 1, 2. Start with the easy ones. When x is 0, 2 to the 0 power is 1. So 3 times 1 is 3. Minus 5 is -2. Order of operations all day. When x is 1, 2 to the first power is 2. 3 times 2 is 6. Minus 5 equals 1. When x is 2, 2 squared is 4. Times 3 is 12. Minus 5 is 7. All right, now let's focus on this one. When x is -1. Well, actually, let's do -2 first. Why not? I'll do that below. When x is -2, that means you have 3 times 2 to the -2 power, minus 5. Think of that as 3 times 1 over 2 to the positive 2 power minus 5. So think of that as 3 over 4 minus 5. 3 over 4 minus 5, to get a common denominator, it's 20 over 4, which equals negative 17 over 4, which is negative 4 1/4. So a lot involving fractions right there. This is going to be negative 4 1/4. And let's do the same thing with negative 1. 3 times 2 to the negative 1 power minus 5. Think of that as 3 times 1 over 2 to the positive 1 power. So 3 over 2 minus 5. Get a common denominator of 2 to subtract those numbers. 3 over 2 minus 10 over 2 equals negative 7 over 2, which is negative 3 1/2. Okay, so now I'm going to graph the 5 values from that table. I'm not going to be able to fit it all on my screen, so I'm just going to go above. We'll start with the easy one, 0, negative 2. Next one we had from the table below is 1, 1. And then we had 2, 7. Now remember what I told you before, the asymptote should be negative 5. So don't go below that. And if you look, you can see you are getting close to negative 5, but never actually touching negative 5. If we did negative 3, it'd be even closer to negative 5, and so on. But I just did 5 values for this one. So we have to graph negative 1, negative 3 1/2, just estimate. And then we had negative 2, negative 4 1/4. Okay, so that's all I got. Let me draw my graph now. Should look like that. Remember, this graph does not go below negative 5. Keep that in mind. That's the asymptote. Okay, so examples 1, 2, and 3, those were exponential graphs. Now we're going to do 3 logarithmic graphs. All right, so here we go. Example 4, graph f of x equals log base 4 of x. Now, this is a logarithmic function, so it's going to have a vertical asymptote. Okay, and if you're not shifting left or right, like this one's not shifting left or right, that means the asymptote is going to be at the y-axis. In other words, x equals 0. So I can tell you ahead of time, this is going to be the asymptote, okay, the y-axis, or x equals 0. So I'm going to do x in my table. Let me copy down f of x equals log base 4 of x. Okay. Now, there's a few ways to do this problem. I don't think any of the ways are actually easy. But think of some, holy voice crack, think of some x values that you can easily get f of x for. In other words, I can easily do log base 4 of 1. I'll explain why in a minute. I can easily do log base 4 of 4. I can easily do log base 4 of 16. That's not going to fit on the graph, but that's okay. I can easily do log base 4 of 1/4, and I can easily do log base 4 of 1/16. Let's start with the easy ones. Do the work over here. Log base 4 of 1 means 4 to what power equals 1? The answer is 0. Anything to the 0 power always equals 1. Think back to the lesson where we evaluated logarithms. How about log base 4 of 4? That's saying 4 to what power equals 4? It's 1. How about log base 4 of 16? That's saying 4 to what power equals 16? The answer is 2. How about log base 4 of 1/4? That's saying 4 to what power equals 1/4? And the answer is -1. Again, think back to the lesson where we evaluated logarithms. How about log base 4 of 1/16? That equals -2. So now we're going to graph this table, keeping in mind that the asymptote is going to be the y-axis. In other words, x equals 0. So start with the easy ones. 1, 0. We have 4, 1. We have 16, 2, which is way out here. We have 1/4 -1. You just estimate that. We have 1/16 -2. So you can see how close it's getting that axis. So let me draw my graph now. Should look like that. How about log 1/3 of x? So again, this one is not shifting left or right. So this asymptote is going to be the vertical line right here, the y-axis. In other words, x equals 0. I believe the next example we're going to do one that shifts. Okay, so x. And we have f of x equals log 1/3 of x. So I'm going to pick x values I can easily get the log of. I can easily do log base 1/3 of 1. I can easily do log base 1/3 of 3, 9, 1/3, and 1/9. That you just have to think logically. Let's start with the easy one. Log base 1/3 of 1. That means 1/3 to what power equals 1? Should know the answer is 0. I'm actually going to do these ones next. I think these are actually easier. Let's do log base 1/3 of 1/3. That's saying 1/3 to what power equals 1/3? And the answer is 1. How about log base 1/3 of 1/9? That's saying 1/3 to what power equals 1/9? And the answer is 2. 1/3 times 1/3 is 1/9. How about log base 1/3 of 3? So that's saying 1/3 to what power equals 3? So if you think about it, this is 3 to the -1 power. So 3 to the -x equals 3 to the first. So -x equals 1. X equals -1. This goes back to the previous lessons. How about log base 1/3 of 9? If you know the answer, you can just put the answer right away. But log base 1/3 of 9 means 1/3 to what power equals 9? So this is 3 to the -1 power. Again, this is from lesson 3. Write them with the same base. -x equals 2. So x equals -2. And let's graph these values from the table. Start with the easy one, 1, 0. Then we had 3, -1 from the table below. Then we had 9, -2 from the table below. We had 1/3 3, just estimate. 1/3 1, just estimate. Then we had 1/9 2. Okay, so let me draw my graph. Again, remember the asymptote is x equals 0. So make sure you don't accidentally go beyond that. It should look like this. Okay, time for probably the hardest one. And then that'll be the end. Okay? The asymptote for this one. Let's think about that. What is the asymptote for this one? Well, there's a few ways to think about that. That -3 means you're shifting to the right 3. So the asymptote is going to be 3. Okay, or think about it like this. The argument, in this case, x minus 3. The argument must be greater than 0. So that means x has got to be greater than 3 when you solve that. So that's the asymptote. Okay, the argument, this thing in parentheses, it's called the argument. That must be greater than 0. So if x minus 3 is greater than 0, then x has to be greater than 3. So that's the asymptote. So what I'm going to do for this one is, because I think this is the hardest one, I'm just going to graph the asymptote. You could probably do this for the earlier ones too. There's really no need to do it if it's at the y-axis or the x-axis. But for these ones, you might want to do it. That's my asymptote. Now, let's go to our table. And you really need to be smart when you pick your x values for this one. This is really difficult. But I'm going to choose x equals 4 for my first x value. Because, if you look at it, you can't even have 3, right? So let's do x equals 4. Let me do that work down below. So we have log base 2 of 4 minus 3 plus 1. That equals log base 2 of 1. Two to what power equals 1? The answer is 0 plus 1 equals 1. Next, I'm going to do x is 5. When I do x is 5, this is what I get. I get log base 2 of 5 minus 3, which is log base 2 of 2. Two to what power equals 2? The answer is 1. So 1 plus 1 equals 2. And here's where it gets tricky. If I choose x equals 6, that's not going to work out nicely. Because I'm going to have log base 2 of 6 minus 3, and that's not going to be a nice number. But if I do x is 7, I get a nice answer. You'll see that right now. If I do log base 2 of 7 minus 3, that is going to be a nice one, because it's going to give me log base 2 of 4, which I can easily do. Because 2 to what power equals 4? 2 plus 1 equals 3. Let's do a couple more. I know the next easy one is going to be x equals 11. Because I know 11 minus 3 will give me 8, which is easy to do. Because log base 2 of 11 minus 3 gives me log base 2 of 8. Log base 2 of 8 is 3 plus 1 equals 4. And I'll do one more. It's not going to fit on the graph, but the next easy one to do would be 19, because log base 2 of 19 minus 3 gives me an easy one. Because it gives me log base 2 of 16. which is easy to do. So that's 4 plus 1 is 5. So let's just graph the ones that actually do fit. We have 4, 1. We had 5, 2. From the table below, we had 7, 3. And we had 11, 4. You can just estimate that one. That one you can do. That's fine. Just go 1 over. And when you draw your graph, make sure you don't go past the asymptote. Okay? And don't just stop right there, because that looks like a square root function. Okay? Continue on. Approach the asymptote. Don't actually touch it. And that looks good like that. I know that was a hard lesson today. Graphing exponential and logarithmic functions, but that is the end of Unit 6.